The International Astronomical Union right now has two options. You either return the status of the planet to Pluto, or you say that the Earth is not a planet, it's a dwarf planet for the very same reason. It didn't clear its neighborhood from other bodies, meaning it has a quasi-satellite, the Moon, meaning having the same orbit, essentially, like one-to-one orbital resonance with Earth, alright? Greetings, this is Eugene the Philosopher, the greatest living philosopher after the unfortunate passing of Quentin Robert de Nameland, who has been the greatest living philosopher before me. In this little video, I'm gonna prove to you that the Earth is not a planet, at least according to IAU, International Astronomical Union's terms, at least their resolution B5 from 2006. You remember when they revoked the status of planet for Pluto? So they should do the same for Earth, for the reasons outlined right now. So in this video I'm gonna prove that the Earth is not a planet. It's a theorem if you wish. I would claim it's a dwarf planet, at least according to IAU, International Astronomical Union definition, alright? The resolution B6, which we're gonna see sometime later. I just checked whether the recording is on, because I just screwed up yet another take. Anyways, so to prove that the Earth is not a planet, a theorem if you wish, we're going to prove a lemma, which is like an auxiliary theorem, and we're going to prove that the Moon is not a satellite, alright? In fact, I would claim that the Moon is a dwarf planet in one-to-one orbital resonance with Earth. So it's a quasi-satellite, not the real satellite. And in order to prove this, we should consider firstly this little factoid, that the Sun pulls the Moon 2.2 times stronger than Earth. Okay, and it's very easy to see. You can make the calculation yourself. Any of my ninth grade students can do this. Hopefully you can do this as well. It's not some big revelation. It has been known for ages at this point. Alright, which means it follows from this little factoid that the orbit around the Sun, of the Moon, that is always convex. So the Moon always falls onto the Sun and never falls onto the Earth. So the Moon actually revolves around the Sun and not around the Earth. The orbit, in air quotes, of the Moon around the Earth is virtual, you might call it. Alright? It's like if you're on the ISS, on board of the ISS, and you throw a little bolt from the airlock, it starts orbiting the ISS because it has some decent mass, like 500 tons, something like that. So a small object can orbit it. Yet you would never, in your wildest dreams, claim that it actually orbits the ISS. It orbits the Earth, just like ISS does, right? So the same situation is true for the Moon. Well, you may say, well, from the Earth's perspective, it looks like the Moon orbits the Earth. Well, sure, but you know what? From Earth's perspective, it looks like the Sun orbits the Earth as well, right? Just like the ancients thought it does. But if you calculate the forces, it becomes apparent that the Earth orbits the Sun, not vice versa. And the same is true for Moon, just like we said here, all right? So why is it important that the orbit is convex? Well, first of all, what it is in the first place. I'm sorry, that's from the previous take. So the orbit of the Moon around the Sun looks like this. It looks like an ellipse. Pretty much the same as the orbit of the Earth around the Sun. Alright? And what the shape is convex. What does it mean? If you draw a tangent at any point, it doesn't cross the orbit itself, right? So a convex... concave rather shape would be I don't know, something like this. So it has these dips, right? Well, the orbit of the Moon is not like this. It doesn't have any dips. So the Earth's influence onto the orbit of the Moon is negligible. Like, oh, I'm sorry, wrong tool. So the orbit of the Moon looks like this, and the Earth only adds a very slight, like, wavy pattern. But I'm exaggerating here, actually, right? So because there are no these convex things. This is not how it looks. It's just basically an ellipse around the Sun. So the Moon is a dwarf planet, a quasi-satellite of Earth, not a true satellite. This is basically my point. Yet another indication of this is that the inclination of Moon's orbit, again in air quotes, around the Earth, with respect to Earth's equator, it changes from about 18 degrees to about 28 in a span of a decade. That's why we have all these, cycles of eclipses, like Saros cycle and things like that. And it's not true for any actual satellite. So with any actual satellite of any planet in the solar system, we have a constant inclination with respect to the mother planet's equator. This is not true for Moon and the Earth for this very reason, because the Moon is not a satellite of Earth, it's a quasi-satellite. Now, I've made a slight exercise using the vis-viva equation. So I've asked the question, well, what happens if the Earth vanishes? Does the orbit of the Moon around the Sun significantly changes? And it doesn't. So let's look at this. So I've actually plotted something else here. Let's return to the Moon. So at perihelion, just for the sake of arbitrariness, I could have chosen any other point, but I chose perihelion. So this is the vernal equinox line. It goes to the right. I consider all the orbits lying in the same plane. This is the plane of the ecliptic. So this is Mercury's orbit. This is Venus. Orange one is the current orbit of the Earth / Moon around the Sun, right? They share the same orbit around the Sun, obviously. And so I've said, like, what happens if you have a magic wand and you make Earth disappear? This is the orbit of Mars, by the way. You make the Earth disappear during, for example, new moon, that's the green line, and full moon, that's the red line. So if the Earth disappears when the moon is a new moon phase, so it's between the Earth and the Sun, it will fall down like this, the green line, right? So as you can see, it's very close to its current orbit, right? And if you make the Earth disappear during full moon phase, it goes into this higher orbit, the red one. And they have these properties. So current orbit of the moon around the Sun, period 1 year, 1 AU semi-major axis. If it falls down, so if you make the Earth disappear during new moon, the new period of the moon around the Sun, period of rotation, would be 0.906 years. Or in terms of the size of the orbit, it's going to be 0.94 AU. So it's a 6% decrease from the current orbit. And during new moon, full moon, the period increases to 1.12 years, which corresponds to the increase in semi-major axis to 1.07 AU, so a 7% increase. And I've just compared this to other satellites of other planets, actual satellites, I should have said, not a quasi-satellite as the moon is to Earth. So for Phobos, for example, you have these stats. So as you can see, it's a much higher increase and decrease correspondingly. For Deimos, it's slightly lower, but still much higher than the moon, basically 2 times higher. And if you go into the outer solar system, the stuff gets really intense. For example, any Galilean satellite, if you switch off Jupiter during a full moon, in air quotes, phase of these satellites, so when they're behind Jupiter from the point of view of the Sun, they are flung out of the system. It's that bad, yes, And if you disable Jupiter, when they're Callisto is the outermost Galilean satellite, okay? So it's like the lowest possible impact of Jupiter to one of its satellites, Galilean ones at least. So it goes into a highly elliptical orbit if you switch off Jupiter. Again, during full moon, it just gets flung out of the system entirely. But during new moon phase, in air quotes, it gets into this highly elliptical orbit with a period of 4.44 years, with a semi-major axis of 2.7 AU, which is like basically a 50% decrease, right? So I've plotted it somewhere here. Let's take a look at it. So there you go. Wait, I need to plot Jupiter's orbit as well. So this is Jupiter's orbit, this is its perihelion. So if we switch Jupiter off here, Callisto starts moving like this around the Sun. So it falls almost below the orbit of Mercury, all right? So this is a very big impact, all right? Like compare this to the moon's changes, these 3 lines, right? It's negligible compared to this. If you switch Jupiter off during Io's new moon, it actually starts rotating backwards, like retrograde orbit around the sun, very similar to this one, by the way. So it's kind of crazy, right, for actual satellites. Like not like the moon at all, which proves, hopefully, once again, or at least demonstrates that the moon is not an actual satellite, it's a quasi-satellite, boys. So hopefully this lemma is proven that the moon is not a satellite, it's a quasi-satellite, it's a dwarf planet, essentially in a 1-to-1 orbital resonance with Earth, so it basically shares the same orbit as Earth. You may claim that maybe it's a captured object, right? It's not a true moon, like it arrived from somewhere else, and Alfvén had the same thoughts, but that's a completely different discussion. And we're only, I'm only considering this point right here, and I think this is proven at this point. So now let's return to our main theorem, that the Earth is not a planet. It's a dwarf planet, according to, once more, this resolution B5 of International Astronomical Union, 2006, right, when they revoked the Pluto status. So this is the new definition they gave, new at least back then, now it's kind of old already, but anyways, the Earth, I would claim, is this, it's a dwarf planet, because it's in orbit around the sun, sure, Earth orbits the sun, has enough mass to become round. I'm sorry all my flat Earth friends, but the Earth is round. And this is the crucial point, the Earth has not cleared its neighborhood, alright? Why? Well, because of this. Because it has a dwarf planet sharing the same orbit, and which is not a satellite of Earth. Okay? Do you understand the point? There is a dwarf planet sharing the same orbit, therefore the neighborhood, in air quotes, is not cleared. Just like Pluto didn't clear its orbit, right? It has Neptune basically crossing its orbit, or very close to doing so. And the same is true for Earth. It has the moon sharing the same orbit, which is a big body. It's like, well, it's not super massive, you know, but it's like 5 times lighter than Mercury, something like this. So it's pretty close, actually. 100 times lighter than the Earth itself, sure. But still, it's pretty big. It's actually bigger than Pluto, the moon is, all right? So yeah, and the Earth is not a satellite, sure, it's not, right? So the Earth is a dwarf planet according to this definition because of point 3. Because the Earth has not cleared its neighborhood, because there is a dwarf planet in the resonance 1-to-1 with the Earth, in the same orbit, essentially. So yeah, hopefully you get the idea. The International Astronomical Union right now has 2 options. You either return the status of the planet to Pluto, or you say that the Earth is not a planet, it's a dwarf planet for the very same reason. It didn't clear its neighborhood from other bodies, meaning it has a quasi-satellite, the moon, meaning having the same orbit, essentially, like 1-to-1 orbital resonance with Earth, alright? If you wish to support me, please consider joining my Patreon. That is patreon.com/philosopher. See the link in the description. Or if you have a scientific theory of your own and you'd like my help in developing it, please join my alternative science coaching program, also available through Patreon.